In this video, we're going to talk about theoretical yield versus the actual yield, and introduce the topic of percent yield. When we've been dealing with stoichiometry, we've been talking about the relative amounts that come together to react in a chemical reaction and the amounts that are formed. And so the theoretical yield is the maximum amount of product that can be formed if the reaction goes to completion. If everything happens ideally, that's what our theoretical yield is. The actual yield is the mass that is recovered after we finish our reaction. Now, the actual yield oftentimes doesn't equal the theoretical yield. And there are different reasons for this. There might be side reactions where other products are formed. An example of this is combustion reactions that take a hydrocarbon plus oxygen, react it to typically make carbon dioxide and water, but there may make some carbon monoxide in the process. Or because there's nitrogen in the air, with different temperatures, we might make various nitric oxides. And so those would be examples of some side reactions. What we measured out in the lab as our reactants may not have been completely pure. And so that would lessen our actual yield. So the impurity of reagents. And then just as we try to recover everything, all of our product, we might not be able to do that. So our inefficiency in recovery of product. If it's a gas, some of it might escape. If it's a solid, when we do our separation or precipitation or filtration and drying or whatever, we might have lost something along the way. And so our actual yield oftentimes is less than our theoretical yield. It can never be more than our theoretical yield. And so at the end, we can calculate a percent yield. That's equal to the actual yield divided by the theoretical yield times 100%. And that's our percent yield. If you wanted to do a simple example, what is the percent yield if 287 grams of iron 2 oxide are recovered in a reaction whose theoretical yield was 301 grams. So we're trying to find the percent yield, so we're just going to plug and chug in this formula. So percent yield is equal to the actual divided by the theoretical times 100%. So 287 grams of Fe2O3 divided by 301 grams of Fe2O3 times 100%. So 287 divided by 301 times 100 will give me 95.3%.